Alright, Module 19 Study Guide. So, identify the following forms of a quadratic equation. First, standard form. Remember, standard form of a quadratic equation is y equals ax squared plus bx plus c. Okay. And if a quadratic is in standard form, you could easily find the axis of symmetry and the vertex by using the formula for the axis of symmetry, which is x equals negative b over 2a. That's the formula for the axis of symmetry. And we find the axis of symmetry when a quadratic is in standard form. Remember this formula for tomorrow's test, very important. All right, number 2. Vertex form of a quadratic equation is y equals a times x minus h squared plus k. Very similar to the vertex form of an absolute value equation. So remember, when a quadratic is in vertex form, we can easily identify the vertex, and that would just be h comma k. And we could also easily identify the axis of symmetry, which would just be x equals h. So find the axis of symmetry and the vertex for these quadratic equations. So remember, axis of symmetry is x equals negative b over 2a. So first, let's label all of our parts. This quadratic is in standard form, which is y equals ax squared plus bx plus c. So what number's in the a position? That would be negative 1. What number's in the b position? That would be 10. And c wouldn't matter when we're finding the axis of symmetry. So for the axis of symmetry, this would be x equals negative b, which would be negative 10, over 2 times negative 1, which would be negative 2. And negative 10 divided by negative 2 would be 5. So remember, to find the vertex, all you would do is plug in your axis of symmetry, x equals 5, and find your y value at that axis of symmetry. So just plug in 5 wherever you see an x. So it's going to be y equals negative 5 squared plus 10 times 5 minus 26. Well, 5 squared is 25. 25 times negative 1 would be negative 25, plus 10 times 5, which is 50, minus 26. Well, negative 25 plus 50 would be positive 25, and positive 25 minus 26 would be negative 1. So, what's your axis of symmetry? Your axis of symmetry is x equals 5. What's your vertex? Your vertex is going to be 5, comma, negative 1. That is it. Number 4. So remember, x equals negative b over 2a. That's how you find the axis of symmetry. And this is in standard form, so y equals ax squared plus bx plus c. So what number is in the a position? 3. What number is in the b position? Negative 6. So if we plug that into our formula, it would be negative 6, or positive 6, divided by 2 times a, which is 3. So this right here is a negative and a negative. That'll turn into a positive 6 over positive 6, which is just 1. And remember, to find your vertex, all you would need to do is plug in your axis of symmetry, or plug in your x value. So this would be 3 times 1 squared minus 6 times 1. Well, 1 squared is 1. 3 times 1 is 3. So this would just be 3 minus 6, which is negative 3. So for number 4, what's your axis of symmetry? Your axis of symmetry is going to be x equals 1. What's your vertex? Your vertex is going to be 1, comma, negative 3. Alright, so next, remember, your standard form is y equals ax squared plus bx plus c. So your b value is going to be the numbers in front of the x. What number is in front of the x in this quadratic equation? Well, we could rewrite this. This is the same thing as saying 2x squared plus 0x minus 4, right? So, what number's in the b place? Be 0. That negative 4 is not in the b position because it's not in front of your variable x. That negative 4 is the c. Okay. So now you would just plug it into your formula. So it'd be x equals negative 0, or just 0 over 2 times 2, which is 4. And that's just going to be 0. So to find your vertex, we would just plug in 0 anywhere we see an x. So your vertex is going to be y equals 2 times 0 squared minus 4. Well, 0 squared is 0. And 2 times 0 is 0. And 0 minus 4 is negative 4. So what's your axis of symmetry? Your axis of symmetry is going to be x equals 0. And what's your vertex? Your vertex is going to be 0, negative 4. Alright, so now we are going to graph each equation using a table of value, then identify each characteristic. So first we're going to define our axis of symmetry and our vertex. So A in this quadratic will be 1, B would be negative 4, C would be negative 3. So for your axis of symmetry, it's going to be x equals negative b, so it would be negative 4, which turn that into a positive 4, over 2 times a, which would be 2 times 1, which is just 2. So your axis of symmetry is 4 divided by 2, which is 2. To find your vertex, you just plug in your axis of symmetry. So that would be y equals 2 squared minus 4 times 2 minus 3. 2 squared is 4. Negative 4 times 2 is negative 8. That's minus 3. 4 minus 8 is negative 4. And negative 4 minus 3 is negative 7. So what is your vertex? Your vertex is 2, negative 7. And remember, that's the point that we put in the middle. So we can already fill some stuff out here. Our axis of symmetry is going to be x equals 2. And our vertex is going to be 2, negative 7. We already know our domain is going to be all reals. All right. Now we just fill out this table to graph it. Okay. So let's go ahead and fill it out. This would be 3 and 4. This would be 1 and 0. So at 0, we're going to be at negative 3. That would mean that at 4, we're also going to be at negative 3. At 1, let's see, it would be 1 squared, which is 1 minus 4, which is 1 minus 4 is negative 3, and then minus another 3 would be negative 6, which would mean that we'd also be at negative 6 when we're at 3. And then we graph this. So our vertex is 2, negative 7, which is right here. And then we have 1 and negative 6, and 3, negative 6. Then we have 0, negative 3, and 4, negative 3. Then you draw your parabola. And your vertex in this case would be a minimum. So what would your range be if your vertex is a minimum? Well, what's the y value of the vertex? That would be negative 7. Because it's a minimum, that means y is going to be greater than or equal to negative 7. Number 7. So first you need to identify the axis of symmetry. So A for number 7 is going to be negative 2. B is going to be negative 8. C is going to be negative 4. So for your axis of symmetry, that would be x equals, remember your formula for the axis of symmetry is negative b over 2a. So that's going to be x equals negative 8, or positive 8, over 2 times negative 2. Well, what's 2 times negative 2? 2 times negative 2 is negative 4. And 8 divided by negative 4 is negative 2. So your axis of symmetry is going to be negative 2. All right, now in order to find the vertex, we just plug in -2. So it's going to be y equals -2 times -2 squared minus 8 times -2 plus, not plus, minus 4. Okay, well, -2 squared is 4, positive 4. Positive 4 times -2 is -8. -8 times -2 is positive 16, then minus 4. -8 plus 16 is 8, and 8 minus 4 is 4. So what is your vertex? Your vertex is -2 and 4, which is what we put in the middle. So we could already fill out some stuff in our little chart here. So our axis of symmetry is going to be x equals -2. Our vertex is going to be -2, 4. We know our domain is going to be all reals. All right, now let's graph it. So let's put -1. I'm sorry, wrong way. -1, 0, and -3, -4. All right. So at -1, what would our y value be? Well, that would be -1 squared, right? Which is 1. And then 1 times -2 is -2. So it'd be -2. Then minus 8 times -1. So that would be plus 8. Then minus 4. Okay? -2 plus 8 is 6, and 6 minus 4 is 2. So -1 would be at 2, which would mean that at -3 we'd also be at 2. Then at 0, we'd be at -4, which would mean at -4 we'd also be at -4. All right? And then we graph it. So our vertex is -2, -4, which is right here. Then we have -1, 2, which is right here. Oops, I messed up. This is not. Oh, what did I do? All right, so that's actually supposed to be -2, 4, which is going to be right here. That's the vertex. Then we have -1, 2, which is over there. And then we have 0, -4, which is right over here. Okay? And then -3, 2, which is right here. And -4, -4, which is right here. Your parabola is opening downwards. That means this is going to be a maximum. And that means our range is going to be less than or equal to whatever that y value of the vertex was, which was 4. So y is less than or equal to 4. All right, so now we have a quadratic that's in vertex form. So remember, vertex form is y equals a times x minus h squared plus k, where h comma k is your vertex and your axis of symmetry is going to be x equals h, right? So, and also remember from our notes what the parent function of a quadratic formula is, which is y equals x squared. Y equals x squared is a parent function. So just before we even start graphing this, we could already kind of see what transformations are going to occur. So we could already kind of figure out what's going to happen in this part of our chart. So it's negative on the outside. It's a negative a. So because it's a negative a, that means it's going to flip. It's going to be pointing downward. So we could already write flip here. Right? That's one of our transformations. What else? So it's minus 1. So because it's minus 1, that means we are going to go to the right 1. Okay? And then we don't have a k, so that's it. Those are the only transformations. So, and we could also already figure out what our vertex is. It's very easy to figure out the vertex when it's already in vertex form. So what number is in the h position? Oh, it's 1. It's -1, but remember h is going to be opposite, so your vertex is going to be 1 comma What number is in the K position? 0. So 1, 0 is your vertex, which would mean that your axis of symmetry is going to be x equals 1. And your vertex is going to be 1, 0. Then we just figure out some more values, fill out our table. Okay, so at 0, where is that going to be? Well, at 0 would be negative 1 squared, which is 1, and 1 times that negative that's on the outside would be negative 1. Okay, at negative 1, let me work this out for you in case you didn't see that. At negative 1, it's going to be negative 1 minus 1 squared. Well, negative 1 minus 1 is negative 2. Negative 2 squared is 4. Well, you still have that negative on the outside, so it'd be negative 4. And these would just be the same. Okay, so we have 1, 0, which is right here. We have 0, negative 1, which is right here. We have negative 1, negative 4, which is right here. And 2, negative 1, 3, negative 4. All right, so your domain, all reals. And your range, this is a maximum, so that means it's going to be y is less than or equal to your y value of your vertex, which is 0. All right, next. So we have 1/2 x plus 4 squared minus 8. So this again is in vertex form. So we could easily identify our vertex. Remember, our vertex is h comma k. Okay, so h would be positive 4, but remember h is going to be opposite. So your h is going to be negative 4, and then your k is going to be negative 8. So our vertex is negative 4, negative 8. That's it. And that we could also figure out our axis symmetry. Our axis symmetry is just going to be x equals h, which is negative 4. The vertex is going to be negative 4, negative 8. Domain is going to be all reals. Now let's talk about the transformations. So we have this 1/2 here on the outside, which is going to mean that compared to our parent function, which is y equals x squared, this is going to be compressed or wider. Okay? What else? It's plus 4. So that means because it's plus 4, we're going to be going to the left 4. And it's minus 8. So because it's minus 8, we are going to go down 8 compared to our parent function. All right. Now let's go ahead and figure out the table here and graph it. So we have negative 3 and negative 2, and then we'll do negative 5 and negative 6. Okay, it's going to be a decimal or fraction, so if we plug in negative 3, looks like we get negative 7.5 or negative 7.5, and if we plug in negative 2, we would get negative 6. Right, and then this would just be negative 7.5 and negative 6. So then we graph it. Your vertex is negative 4, negative 8, which is going to be right here. Then we have negative 3, negative 7.5, which is going to be right here. Then we have negative 2, negative 6, which is going to be right here. All right, might have made it a little too wide, but that's it. That's your That's your graph. So it's going to be wider, or a compression. It's going to go to the left 4 and down 8. All right, without graphing, describe the transformation of each equation from its parent function. So remember, the parent function is y equals x squared. So here we have a plus 4. So that would be a change in your k, right? So remember, the standard form of an equation is y equals a times x minus h squared plus k. So that 4 represents the k, which means it's going to be that means we're going to be going up 4 spaces. This negative right here would mean that we are going to be reflecting across the y-axis, or it's going to be flipped. So up 4 spaces and flipped, or reflected across the y-axis. I'm sorry, not the y-axis, the x-axis, reflected across the x-axis. All right, next we have this. So we're changing the h. It's -6, which would mean that we'd be going to the right 6. Remember, h is opposite. So we're going to the right 6. Then we have a -2 in the k position, so that means we are going down 2. Then we have 3 here, which means we're going to get a stretch, which is going to become narrower. So we're going to have a stretch by 3. All right, so remember, our parent function is y equals x squared. So if we go 3 units down, that's affecting the k portion of our parent function. Remember, the standard form of a quadratic is in vertex form. I'm sorry, I said standard form. The vertex form of a quadratic is y equals a times x minus h squared plus k, right? So if we're going 3 units down, we're affecting the k. So that's just going to change this to y equals x squared. And since it's 3 units down, it'll be -3. 7 units to the right and 2 units up. That means we're going to be affecting the h and the k. So 7 units to the right would be affecting the h. So that would mean x, and it's to the right. So right would be -7 squared. And then 2 units up would be +2. Reflected, that means it's going to be negative over the x-axis, then translated 5 units to the left. So that's going to be to the left, means we're going to be affecting the h. So that would be -x, and since it's to the left, it'll be +5 squared. And last but not least, vertically stretched by a factor of 2. That means we're going to be multiplying this by 2. So it's going to be y equals 2 times, then translated 4 units to the left. So x, remember left, that's horizontal, so that's going to be your h, and it's to the left, so that would be +4. And then 1 unit down would be -1. What's wrong with this? There we go, -1. And that is it. That's your study guide. Be prepared for tomorrow's test. That's all I have for you. See you tomorrow.